Hello friends, welcome to my channel. In this video I will cover most important questions for Vizag Steel MT, SSC JE, Isro Scientist and Technical Assistant Production Casting part I will cover. This is part 11. This type of question in SSC JE they won't ask, but in Isro they may ask. Isro and IAS also they may ask. Question is, a mold has a down screw whose length 20 cm and cross sectional area at the base of the down screw is 1 cm square. The down screw feeds a horizontal runner leading into the mold cavity of volume given 1000 cm cube. The time required to fill the mold cavity is how much? It's a down screw. Then so data given are from this point to this point, length is 20 centimeter. Let it be 1 1, here 2 2. Then down screw at the base of down screw at 2 2. Here area is, height is, first you write height is 20 centimeter. Then A2 is 1 centimeter square. Volume of mold cavity volume is 1000 centimeter cube. So from here we will calculate velocity at point 22. We will apply Bernoulli's equation here. Then finally we will get it's equal to 2gh root over g in centimeter you have to calculate. So 2 into 9.81 into 100 into h is 20 root over, or you divide here. If you keep it in oscillation term, oscillation is here meter per second square term. You keep it as g in meter per second square term, and h you divide 100 in meter term. You will get 1.981 meter per second. This is velocity at point 2. And volume given, we know area into velocity. This is volume flow rate, or total volume is, this is, you can write it as volume flow rate, total volume divided by time. So from here you will get time. Time is total mold volume divided by area into velocity V2. So if you put the values, volume is, here we will write volume is 1000 centimeter cube, 1000 centimeter cube divided by 10 to the power 6 into area also in centimeter square, divided by area 1 divided by 10 to the power 4 divided by V2 is 1.981 into 1.981. If you solve this one, finally you will get time equal to 5.05 seconds. In GATE they will allow calculator, so don't worry, B will be your answer. Same question already asked in other exam also, IAS and PSU exams. The primary purpose of a screw in casting mold is feed the casting at a rate consistent with the rate of solidification. For reservoir we are using riser. Feeding molten metal from pouring basin to gate. No. Third is feed the molten metal from the pouring basin to the gate. Wait. A is feed the casting at a rate consistent with the rate of solidification. This is for in-gate or gate. In-gate or simply gate. And feed the molten metal from the pouring basin to the gate. This is the correct answer. For screw you will get here. Then runner. Then finally gate. Then mold cavity. Then riser. So here for in-gate, this one, in-gate, for feed the casting at a rate consistent with the rate of solidification. And riser, this is riser, act as reservoir for molten metal. Then for screw feed the molten metal from the pouring basin to the gate. Pouring basin is here. It's like this. This one pouring basin. Pouring basin. In solidification of metal during casting, compensation for solid contraction. For solid contraction, this one also already discussed in IES paper in different year. Provided by oversized pattern. For solid contraction, oversized pattern. This is correct. And for riser we are using for liquid contraction, and solidification contraction from liquid state to solid state. Phase change, solidification, contraction. For these two we are using riser, and for solid contraction, from solid state to room temperature we are using oversized pattern. Both are important. For directional solidification we are using chills and padding. This is also important. Question is, which of the following materials can be used for making patterns? For making patterns, aluminum, yes, possible. Wax, also possible. Mercury, also possible. Lead, not possible. So, from option 1, 2, 3, D is our answer. In Isro, they may ask this type of question. Grey cast iron blocks 200 into 100 into 10 mm are to be cast in sand mold. Shrinkage allowance for pattern making is 1%. The ratio of volume of pattern to that of casting will be how much? So, initial volume is 200 into 100 into 10. Shrinkage allowance is 1%. So, final volume of pattern, final volume VF is 200 plus 1% of 200, 1 by 100 into 200. This is for length. Then for 100, it's 100 plus 1 by 100 into 100 into for 10, 10 plus 10 by 100, 1 by 100 into 10. Then you will get final volume. Here you will get 202 into 101 into 10.1. This is final volume. So ratio of volume of pattern to that of casting. Ratio is, so multiply 202 into 101 into 10.1 divided by casting volume is 200 into 100 into 10. If you solve this one, you will get 1.03. So from option D is our answer. This one also repeating question, already discussed. Three type of, from here liquid stage to solidification stage, 1 to 2, 2 to 3 phase change, liquid to solid phase, then 3 to 4. 3 is that phase change temperature to 4 is room temperature. So here we are giving 3 to 4, we are giving pattern allowance. Pattern, it compensates this allowance, and from 1 to 2 and 2 to 3 this shrinkage compensated by riser. Riser compensates 1 to 2 and 2 to 3. 1 to 2 is liquid shrinkage and 2 to 3 is solidification shrinkage, and 3 to 4 is solid shrinkage. These terms are also very important. So in this question, shrinkage allowance on pattern is provided to compensate for shrinkage. This point is 3 to 4 solid shrinkage. The temperature of liquid metal drops from pouring to freezing temperature. No. Pouring temperature is this one, 1, and here freezing temperature is 2 to 3. No. For this we are using riser. The metal changes from liquid to solid state as freezing temperature. This is 2 to 3. For 2 to 3 also we are using riser. Then temperature of solid phase drops from freezing temperature to room temperature. Freezing temperature is 3 point, then room temperature is 4 point. There we are using pattern. So this is correct answer. C is the correct answer. Then the temperature of metal drops from pouring to room temperature. Pouring temperature is at 0.1 and room temperature is at 0.4. Here we are using both riser and pattern. In some exams directly they are asking this question without changing any options also, so you just remember the options. In the grain size determination using standard charts, the relation between the given size of number small n and the average number of grains capital N per square inch at the magnification of 100x is how much? It's n equal to 2 to the power minus n, 2 to the power small n minus 1. So B is your answer. Just remember this one. Hardness of green sand mold increases with increase in moisture. No. If you increase moisture, hardness will decrease. Increase in permeability also, if you increase, hardness will decrease. So decrease in permeability, this is the answer. If permeability decreases, hardness will increase. Permeability decreases means gap will decrease, so hardness will increase. Consider the following statements. The actual entry point through which the molten metal enters the mold cavity is called in-gate. Correct. Bottom gate in case of mold creates unfavorable temperature gradient. Top gate we are using if this is the mold cavity. At top we are feeding. This is top gate system. And this entry point we are calling as in gate. And in bottom gating system we will use like this. This one is not available. Here small opening. This is the mold cavity. Riser where we are providing. So at the bottom point we will feed the molten metal. So bottom gate system. This is bottom gate system. Then screw in case of mold is made tapered to avoid air inclusion. Correct. So from option in gate is correct. Then bottom gate in case of mold creates unfavorable temperature gradient. No. And screw in case of mold is made tapered to avoid air inclusion. This is screw. This is correct. So 1 and 3. C, D option is not available here. 1 and 3. D is your answer. The gating ratio 2:8:1 for copper in gating system design refers to the ratio of areas of first screw will come, then runner, then ingate. Screw is 2:8, 8 is runner, then ingate. So from option screw, runner, ingate, A is our answer. In gating system design, which one of the following is the correct sequence in which choke area, pouring time, pouring basin, screw sizes are calculated? So first we will start from choke area. Choke area is the minimum area at the exit of screw. Here at 0.33. This is choke area. Then we will calculate pouring time. By applying Bernoulli's equation, we will calculate pouring time, then pouring basin size, then screw. So A is our answer. Which of the following are the requirements of an ideal gating system? For ideal gating system, 1. The molten metal should enter the mold cavity with high velocity. No. If it will enter with high velocity, then mold erosion will occur or mold cavity erosion will occur. Air may be entrapped inside the mold. So 1 is not possible. Then second one, it should facilitate complete filling of the mold cavity. Yes, this is correct. It should be able to prevent the absorption of air or gases from the surrounding on the molten metal while flowing through it. Yes, this is also correct. So 2 and 3 from option C is our answer. Which one of the following gating system is best suited to obtain directional solidification? Already top gating system and bottom gating system figure I already gave. For part line gating system, you will provide your gate at parting line. Then stepped gating system, step by step, you will give the molten metal to flow into the mold cavity. So step is better for directional solidification. D is your answer. This is part line gating system figure. A sand casting mold assembly is shown in the above figure. The elements marked A and B are respectively A and B. Here, this is parting line. This middle line, it's parting line. Above the parting line, cope. And below parting line, it's drag. Then here A is your riser. This is mold cavity. Mold cavity. Then B is your screw. screw, then your runner, your entry point you will get in gate. So from option A and B, A is your riser, B your screw. A is your answer. This is the end of part 11. Thank you friends. Thank you for watching my video. Thank you.